All right, the last thing we're going to look at now are solids and liquids, and as you can tell, there's a lot more going on with gases than there are with solids or liquids. Okay, liquids also can be applied to the kinetic molecular theory, talking about just the fact that they're in constant motion. Liquids always are moving as well, right? But liquids are more dense than gases because the forces that hold them together are stronger. And we're going to talk more about these forces later. They're called intermolecular forces because they are the forces between molecules, okay? But they are more dense because their forces that attract them together are a lot stronger. Plus, they usually also have less kinetic energy, so they can't break these forces between their molecules nearly as easily. Okay, they're considered incompressible because there's basically no space between these particles. Remember, if you've got like a liquid, okay, they're not taking up the entire container. All right, they have a very definite volume, but they'll take the shape of whatever container they're put in. Liquids also flow very easily, okay, but they're not going to flow nearly as easily as, say, a gas. Gases have more kinetic energy, they take up more space, they're further apart, they move a lot easier past one another. They have more kinetic energy. Okay, along with liquids, we have what's called viscosity, all right, and viscosity is the resistance to flow, all right. If you have a liquid that has a stronger force between them, holding them together, they're going to have a higher viscosity, okay. As your temperature for something goes down, your particles tend to have less kinetic energy, so there's more resistance to flow. Molasses is a very good example of something that has a very high viscosity. Okay, if you heat it up, it'll have a little bit lower because your particles have a little bit more kinetic energy. They're moving a little bit faster, so they can flow a little bit easier. But that's basically viscosity, how much they don't want to flow. Okay, the last thing I'm going to look at are solids, and some properties of solids. So we drew liquids up here. Okay, that are getting a little bit closer together. Now we're going to deal with solids. Solids will be even closer together. Okay, they have their own definite shape. They have their own definite volume. Okay, now don't think though that solid particles aren't in constant motion because they are. Okay, but they have such high attractions for one another, and they have such low kinetic energy that they can only vibrate in place back and forth. They don't actually slide around. They just vibrate in the place that they are in. Most have more dense as solids than they do as liquids. Water is an exception to that rule. Okay, there are kind of two types of solids we're going to look at here. Okay, the first one is a crystalline solid. They're just what they sound like. They're crystals. So they are orderly arrays of particles. They have a very geometric structure. Okay, they have a building block that's called a unit cell, which has the same symmetry as the entire crystal. Think of that as one brick. That one brick has the same structure as the entire rest of the molecule, which makes them very ordered. Okay, there are actually 5 types of crystalline solids we'll look at later on in the year. The last thing are what we call amorphous solids. These have no regular repeating pattern. They also don't have any crystals. And they will often form when materials cool too quickly. So crystals can't actually form. Crystals only really form with a slow cooling process. Some good examples of these are glass and rubber. Those are both amorphous solids. I always think these are like amorphous blob. There's not really any actual pattern with them.